In this video, I am going to show you how to find the gradient of this function here. So f of xy equals x minus y. And then we'll also take a look at the picture of the gradient, okay, in the plane here. So this is my friend here. How you doing? You see, he's always happy. So the first step is this. You've got to calculate the partial derivatives of the function. So let's color code here so it's easier to see. The gradient notation looks like this, and this is a function of x and y. And there's a space here, and then there's another space here, and this is your j, and this one here is the I component. So these are the gaps we have to fill, and into this space we have to, in this space, and rather we have to park the partial with respect to x, and in this space we have to park the partial with respect to y. So let's do that right now. So there are many ways of writing partial derivatives. The compact one that I like is this one. This means the partial with respect to x, and that is simply equal to 1. The y is constant and it goes away, and all you have is the derivative of x with respect to x, which is 1. The partial with respect to y is once again just negative 1. So all you do now is stick these into the blanks. So 1i plus a negative j. So this is the gradient of this function. So this one is constant. Okay, let's rewrite it so it's a little more. What we have is an I minus a j. Okay, there we are. So that's the gradient of this function, I minus j. And another exercise in this context is sketch a level curve of the function and then sketch the gradient. So let me use another color here for the level curves and the axes. So the first step is make sure you can draw a good coordinate system. I'm going to use here too. There we go. So that's our y-axis. This is the x-axis. Another question is, how do you draw a level curve of the function? Well, that's fairly easy. All you do is set it equal to a constant, and then that's how you draw level curves. So that means the following. We will take our function here, x minus y equals 1. For example, I'm arbitrarily setting it equal to 1, just so I can sketch a level curve of the function. Once it's sketched this way, what you can do now is graph this by using intercepts. Okay, so that's a basic concept from algebra, which is graph a line using its x and y intercepts. Perhaps it's been a while since you've seen it. So let's do this. Once we have our axes, you want to definitely mark them. So let's mark these up here so they look good. There you go. You should always make your work so that if you look at it 2 weeks from now, it will still make perfect sense. You can follow the steps. Okay, there we are. So these are our axes. This is a level curve of the function, a level set, a contour curve. Those are all different names for the same thing. Well, once this is in place, the next move is this. Take this and graph it. So that will look like this. To find the x-intercept, you set y equal to 0. And that means that x equals 1. So you mark x equals 1. To find the y-intercept, you set x equal to 0. So what remains is negative y equals 1, which means y equals negative 1. There we are. So of course, connect these with a straight line. So what I've drawn now is one of the level curves of this function. This is the one that corresponds to level 1, okay? Once this is in place, this guy's like, yes, excellent. So he's got a PhD in mathematics, so he knows this stuff inside out. Okay. Now, let's draw a picture of the gradient. What are the components of the gradient? There's a positive 1, and in front of the j, though we might not write it, there is a negative 1, right? Like this. So those are the components of the gradient. 1i and minus 1j. So that means choosing any point you like, draw that gradient as follows. begin, for example, at this point here, draw 1 to the right. So in our case, 1 means 2 spaces. So 1 to the right means roughly this. This is the x component of the gradient. And then 1 down, so that means it's the y component of the gradient, which means that the gradient itself at this point is this area right there. Yeah, that's the gradient. And it's a vector, and it lies in the xy plane. So here you may want to mark this as this is the gradient evaluated at some point xy. Now here the gradient is constant, so it doesn't matter. It's always 1i minus 1j. Okay, so that's the basic setup for this kind of exercise. Function, find the gradient. In this case, it's constant. It's 1i minus 1j. The gradient comes from finding the partials, as I've done here. If you, in this case, want to plot the level curves, you have to use the concept of graphing by x and y intercepts. Then you can draw a picture of the gradient, and the gradient is perpendicular to level curves. And that's it. Thank you for watching. Have a great day, and don't forget to smile. There you go.